We're reaching the final videos on this category, and I'm so sad because it's coming to an end. But hopefully for you, this is the beginning of a new journey, a new chapter for your reassessment. So let us get started on this problem, right? We need to multiply imaginary numbers. So when we're multiplying imaginary numbers, well, before we do anything, let's start off, right? We have I is equal to the square root of -1. Right, we have that I is equal to the square root of -1. We've defined it to be that, right? I is equal to the square root of -1. Well, what happens, right, if we do I times I, which is the same thing as I squared, right? Well, we said that I was equal to the square root of -1. So if we were to plug this back into here, right, so we're going to get is equal to the square root of -1 squared. Well, what's going to happen with the square and the square root? They're going to cancel, and we're just going to get -1, right? So we can see here that I squared is just equal to -1. So why is this two things useful when we go to solve problems down below, like multiplying imaginary numbers? Well, I'll show you, right? So we have I squared is equal to -1, right? This is what we just showed up above. So let's look at an example problem. Let's say we have 2 plus 3i multiplied by 3 plus 4i. Okay. Well, just like we do with any problem, it's multiplication, so we got to use the distributive property. So what's 2 times 3? Well, I get 6. We get plus. What's 2 times 4i? Well, 2 times 4i, it's going to be 8i. Now we go over here. What's 3i times 3? Well, that's going to give me 9i. All right. And what's 3i times 4i? Well, now we have to be careful here, right? Because pretend that this was 3x times 4x, right? Well, this would be 12 times x squared. But instead of an x, we have an I. 3i times 4i. So that's going to be 12i squared. So we're going to get plus 12i squared. All right. So here we're down below, we're going to get 6 plus, well, 8 plus 9 is going to give me 17i. And then we have plus 12i squared, right? Change the color there, right? No, we just said I squared is equal to -1. So we just plug that back in and replace this entire expression here. So we're going to get 6 plus 17i plus 12 times -1. Because the entire I squared is equal to -1. It's written right up here, right? Well, 12 times negative, so we're going to get 6 plus 17i minus 12. And now we just put these numbers together. We're going to get 6 minus 12 is minus 6, right? 6 minus 12 is -6, and we still have this plus 17i. And this is my final answer here. Okay. Well, let's just go ahead and do one more example problem together, right? Let's say -2 minus 7i, okay, times 3 plus 5i. All right, well, just like before, we do the distributive property. -2 times 3 is going to be -6. -2 times 5i is going to give me minus 10i. And then -7i times 3 is going to give me -21i. And then -7i times 5i is going to give me 5, 10, 15, 20, 25, 30, 35, -35i squared. I'll just simplify this. -6, right? Well, -10i minus 21i is minus 31i minus 35i squared. Okay, now remember, we said I squared was equal to -1. Well, we could just replace then the I squared with a -1, right? And if we go ahead and do that down below here, we're going to get -6 minus 31i, all right, minus 35 times -1. We just replace it, right? And now, all All right, well, what's negative times a negative here? Well, they become a positive, right? So we're going to get negative 6 minus 31i plus 35. Okay. And last but not least, all we have to do now is just combine these two expressions here together, right? So we have a negative 6 plus 35, and so that's going to give me, and that's from negative 6 plus the 35 here. Negative 6 plus the 35 give me the 29 here, right? And then we have this negative 31i, which is what goes down right over here. So there we go. That's our final answer, and we should feel pretty good about that, right? So hopefully going through these two example problems, right, and this big idea here that if we have I squared, that's just the same thing as negative 1. It helps us to simplify problems where you're multiplying imaginary numbers. Take care and